It creates curvature in space-time, and bodies follow that curvature. When he first came up with his equation in 1915, it predicted the orbit of Mercury, I think, up to the fourth decimal. Given the computational technology of the time, that was more accurate than anything you could find. Now it predicts it up to 16 digits. It's so accurate. So models or theories, there are no bad models. There are models that are used in wrong contexts. Okay. So Newton's model of planetary motion is proper if you're going to predict the orbit of Earth, but not for Mercury. Similarly, we're going to use the much more sophisticated models in upper level finance classes. They're more appropriate in more complicated scenarios. But if you could make some simplifying assumptions, we can come up with some good first approximations. That's what we're going to do. So we're going to assume some structures about the nature of future expected dividends. This is going to simplify the calculations quite a bit. First one, I'm going to call that case 0. This assumes that dividends are constant. Whatever it was last year or whatever it is expected next year, they're constant. Coke is expected to pay 194 next year. This case assumes that those dividends are going to stay at 194. If you kind of to work out the math, well, dividends are always going to be equal to D1. If you know anything about the summation notation, a constant comes out of the summation. So that's you're probably saying, am I supposed to add up infinite number of numbers? The beauty of mathematics is you don't have to, because you can. This is called a series sum, and it is convergence. Let me give you an example. This is only for your benefit. You don't have to know this. Suppose my R is 5%. What am I doing? The first one is 1 over 1 plus R raised to the power of that. And I'm going to calculate all of these. Let me increase that quite a bit. After 300 years, it's basically a very small number. But let's kind of do running some of those. And I'm going to do a chart of that. As you can see, that sum comes very close to the 20 without actually being 20. But every year you add a smaller and smaller term. Let me put that. Basically, after about 250 years, the sum doesn't change up to 4 decimals. If I add more decimals, it will be changing. It comes closer and closer. We can actually, if you guys have taken Algebra 2 or Calculus, there are methods to figure out what that sum is going to be. And you should not have to have had those to know what it is. It turns out this sum is equal to 1 over r. So if I calculate the present values of $1 and add them up, if the rate of return is 5%, that present value is 20. If rate of return is 10%, that present value is 10, so on and so forth. So given that, so if Coke is paying 194 next year and the proper discount rate for Coke is 10%, then Coke should be worth $19.40, right? Of course, this is a very simple model. If you have a company that you can reliably think that they will never change those dividends, this is the proper model. But if you have companies that actually grow those dividends, then this is not. Second simplification we're going to do, we're going to recognize that dividends are not constant, but they grow at a constant rate. Say G, which means dividends grow using this equation of motion. If you have $1 dividend this year, next year, and the growth rate is 10%, next year you should expect $1.10, right? Under this assumption, if you worked out the infinite sum, provided discount rate is greater than G, right? And you can always say, if I told you the expected dividend this year or next year, and I ask you to figure out dividends in year 11, then you're going to grow that $1 dividend, let's say, for 10 years at a rate of 10%, 5%, whatever the number is. If the growth rate is greater than the discount rate. Obviously, this would give you a negative number, which is nonsensical. The reason that is nonsensical, and this infinite sum is not convergent if growth rate is greater than the discount rate, right? Let's find two companies that may be appropriate candidates for constant rate of growth, at least, over a longer period of time. Let's think of JPM, uh, Chase, JP Morgan Bank, and Bank of America, right?